Okay, guys, we're back. I hope that you have your sugar rush and you're ready for the next speakers that will be coming up. And we want to just let you know we've managed to sell up to €500 worth of raffle tickets. So just please help us in getting as many as you can, as well as cross your fingers that you're the one that gets the Xbox and I don't take it home with me. I'm just messing because I'm not allowed to enter. So our next speaker is a ShipItCon OG girl boss, one of my favorites, returning back onto the stage once again, who, despite having memories of sitting in this very room completing exams, she still manages to come back each year and grace us with her presence. Laura Nolan. Laura is currently working for a one-year-old startup called Stanza, aiming to make better tools for software reliability. Stanza's first product is smart load shedding on Pivot In. She's also working towards her master's in science in human factors and system safety at Lund University, Sweden. So bringing you this talk about what the software industry can learn from 1980s style human factors research, please give a huge ShipItCon welcome to Laura Nolan.
Thank you so much. Hopefully this clicker is going to work a bit better for me than the last speaker. I was in awe at how well he did, though. I mean, that was amazing. But yeah, fear of the unknown. Where are we? Okay. So a brief sort of visual biography of me. I've contributed to like a bunch of books on site reliability engineering, because that was what I was doing for the last decade or so at places like Google and at Slack. I've done a lot of volunteering with Usenix around the SREcon conference for a great organization called Code Your Future. I've helped them build a software infrastructure-focused course for underprivileged people. And I've worked a lot, bizarrely, with the campaign to stop killer robots, because I don't think that we should let the automation kill people. And as mentioned, I'm currently working on a master's in human factors and system safety at Lund University. And this talk is very much coming out of what I'm doing there. So these are two of the big sort of events that have shaped how people have been thinking about safety and about human factors over the past few decades. So on the left here, we have 3 Mile Island. And this obviously was a big nuclear disaster. And at the time, this really spawned this massive interest in thinking about how operators can make sense of a system and understand that system and make good decisions about the system and get feedback from that system. In short, human factors at that time, they wanted to be in the nuclear control room, thinking about how people are interacting with systems. There was also a lot of work happening in aviation around, cockpit operations and other related industries as well, thinking about things like controlling electrical grids and controlling rail systems. There was a lot of, there's a huge amount of interest in this, and a huge amount of work happened in that area. Then, as we get into the 90s and the noughties, we have a focus on a very, very different type of incident. So here, this is the front page of the massive and very interesting report that was done on the Columbia shuttle incident, which also followed the previous Challenger shuttle incident. And both of these incidents were seen as having a very different origin to the likes of 3 Mile Island. In the 90s and in the early noughties, practitioners in human factors and safety science were thinking about the organizational causes of incidents. Because there was this sort of interesting pattern that happened in both of Columbia and Challenger, where things were going sort of gradually wrong with particular systems, and there were all these signs that, in the case of Challenger, that the O-rings were not behaving as intended, and in the case of Columbia, that the foam strikes and the tiles were not behaving as intended. But the NASA, in both cases, sort of convinced itself that everything was grand and they should just crack on with their launch schedule, resulting in 2 disasters. So when that happened, the whole field of human factors and system safety kind of took this big U-turn, and it said, okay, how do we help these big organizations avoid these kinds of organizational accidents? Now, the other part of history is that shortly after this, the DevOps movement gets started. And part of DevOps has always been, and also SRE and all these sorts of related software engineering disciplines, they've thought a lot about what we can take from human factors and system safety as well. There's been a lot of stuff that's percolated in. But because of the time that DevOps and SRE get started, what we're getting is the sort of the current wave of stuff around organizational resilience. So we get all this focus on doing good incident reviews and learning from incidents and sort of building resilience in our organizations and in our systems to some extent. But we never went back to the 80s and said, what can we take away from the older human factors stuff that our industry just missed out on? So this talk, we're going back to the 80s. What can we learn? What, if we set aside for now, and it's very good stuff, and we should be thinking about organizational resilience and organizational accidents and all this kind of stuff. It's great stuff, but we need to go back to the 80s and get the other stuff as well. So, hands up here, whoever pushes to prod or, writes Kubernetes manifests or, writes chef scripts or any of this stuff. Whoever, who touches prod? Okay, a lot of you, right. We are special users of software, those of us who do that, because we are part of a system now with a whole bunch of different types of software that we're using to manage our systems. We're doing cognitive work in parallel with and interacting with all of these systems. And cognitive work is stuff like knowing things and understanding things, which is subtly different, making plans, and deciding what order to do steps in and why, making decisions, solving problems, investigating things, assessing situations and making judgments. People who are operating software systems do this work all the time. And this concept that came about after 3 Mile Island was this idea of joint cognitive systems. This idea that some systems exist where the thinking is kind of distributed between the automated systems and the humans. And this was not new at the time. This idea that you have automation and you give some responsibilities to people and some responsibilities to machines, but the novelty here is saying you can't just think about these parts of these systems in isolation. You have to think about them together, and how does the automated part influence the person and vice versa? Because that's the thing about systems, parts interact and they affect things over here, affect things over there, right? So these are the 2 books that are sort of the fundamental foundations of this particular topic. And at one point last year, I spent an entire weekend reading both of them and saying, okay, well, how does this apply to what we do in our industry? And so this talk is it's a bunch of content from these books that I've tried to relate to what we do and filter it through the lens of software operations. Now, many of you will probably have read this paper. Who has read Ironies of Automation by Lisanne Bainbridge? Oh, okay, if I said this at SRECon, I'd get like half the hands up. This is a great paper as well. So this is from 40 years ago now. This paper is 40 years old. People still reference it constantly. And it's a great short paper, and she sets out problems 40 years ago that are still not solved. And the problem is basically, when you introduce automation into your system, you make your operators' jobs harder, because there's a few reasons. First off, it tends to be that when we automate something, we automate the easy, predictable parts. And there's always like some leftover stuff that you can't automate, the hard stuff, and we say, okay, well, the person will do that. But now you've made the person's life harder because this is fine initially when your system is introduced. 5 years later, you'll have a bunch of people who've never done the routine parts, and all they have to do is try and pick up the complicated parts. Now your mental model of that system is eroding. And the second part is these operators who are working with these systems, they have to understand not only the underlying system, say, for example, your production software system and what it does, but you have to understand all the automation around it, like your Kubernetes or your Argo CD or your AWS autoscaling groups or your custom scripts that do bits and pieces. So you have to understand a lot of stuff, and this makes life quite hard for operators. And this, in some ways, I think, is getting very much at the same problem that joint cognitive systems are. right? Ironies of automation, this is the software operations life. So, joint cognitive systems in software. Your monitoring and alerting systems, they're part of your joint cognitive system. You're using them to understand and to analyze things. And your obviously your particular configurations. Your CI/CD systems, most definitely, what are these things actually validating before they push? How are they pushing? What happens if it falls over halfway through? There's a lot of stuff there. All sorts of configuration management, from your old school Chef to your fancy new Kubernetes operators, orchestration in general. The consoles and status pages, so the likes of your AWS consoles, your console, status pages that you might have for your load balancing proxies, all this stuff. Your runbooks. Your runbooks are hopefully the distilled advice of all your colleagues telling you what to do when something weird happens, or if you need to do something routine. These are part of your joint cognitive system. This is your team knowledge trying to embody itself. And your logs and your metrics. And this is not an exhaustive list. This is just the top 8 things that came to mind when I sat down to write this list. We are building and creating and maintaining joint cognitive systems all the time, but most of us don't even know what a joint cognitive system is. I think that explains a lot. So are we doing a good job? And I wrote these slides, last week, and this was just something that had popped up on Hacker News that day. We are not doing a good job. If we were doing a good job, people would not be accidentally nuking their sites. And even this happens. It doesn't happen all the time, every day, but it happens. And this is not even the first time I've seen somebody do this with Argo CD. Skyscanner had a very similar outage a couple of years back where they took down their entire site. They didn't lose all their backups, but they took down their site. So we are failing, I think. Because if we were doing a good job, with the tools, people wouldn't be finding themselves in these kinds of situations. So, now we get into the actually actionable part of the talk. I have 2 big anti-patterns here. The first anti-pattern is called automation surprise. We want to avoid surprising the operators, right? And the second pattern is, I kind of call it, Clippy for prod, but it's, it needs a better name. But the idea here is building systems that make really definitive suggestions to people. That's bad as well, for reasons that we'll get into. So 2 anti-patterns. So automation surprise is basically any time that you are working with your system and you say, why is it doing that? What's it going to do next? What's going on? Those moments when you feel like the machines are running amok and you do not understand what's happening and what's going to happen next. Automation surprise has been studied really extensively in aviation, in people working with autopilots and those kinds of systems. But I think we have these problems as well. There are 2 main reasons why we get automation surprise. So the first off is autonomous processes. So these are things that are running by themselves in the background and able to take action when some set of conditions occurs. So any sort of runaway automation that might take down your systems with a coordinated restart because your auto-scaling went bananas because the metrics went weird. That could be an example of an autonomous process going bananas. Then we have human-triggered process, like I meant to do something and I ran a script or I clicked a button and something else happened that I did not expect. So one way I think that we can avoid the autonomous processing issue, or at least make it less likely, is to be very careful about how we build autonomy into our systems. So a lot of places that have sort of been scrappy and been around for a few years and have a bit of tech debt, I think it's very common to see things like scattered cron job scripts and little bits and pieces of tooling here and there that sort of do things under certain conditions. And what you kind of end up with is like this scattered Rube Goldberg machine that becomes very hard to predict. So one of the things that I think is a much better pattern is if you can try and centralize your automation, your autonomous kind of self-running automation stuff into a full-fledged service. Make it something that runs as a first-class citizen, not some little cron job somewhere, something that's got monitoring, something that's got a status page, something that people actually interact with on a reasonably regular basis, as opposed to something that sits here until it's forgotten about and then does something disastrous. The other thing is try and make the behavior as simple and predictable as you can. Particularly in cockpit automation, one of the things that constantly surprises pilots is the number of modes that exist in autopilot software. Try not to build modes into your systems. Try not to build automation that behaves this way on a Tuesday and this other way on a Friday when something else is happening. For example, you might want to avoid building software that goes into different states and that has radically different behavior. Or if you do that, try and make it really obvious what the state is and why these things are happening. But in general, I think avoiding behavior that varies is quite nice. Unattended upgrades is, I think, a great example of a piece of autonomous automation that does sometimes bite organizations, and quite badly. I know of several instances of this, but one that's well documented is the big incident that Datadog had in March. They were down for most of a day, and it was because unattended upgrades, which they sort of had always had and never really thought about, and I think nobody ever really made a decision that they should be doing this automated upgrading within the same hour every day globally. Because this was contrary to their normal processes. They normally try to do things in a phased way. But on this day, unattended upgrade mangled their networking and took them down completely. Unattended upgrades, they have no central coordination, they have no validation, and they have no visibility. You don't see them, you don't have an awareness that they're there. So I think most people consider these an anti-pattern if you're running a service that you want to have high availability, or if it's a large, complex service like Datadog, where doing a big restart is bad and gives you all these thundering herd problems. For all kinds of automation that you build, it's really important to clearly display what's going to happen. Status displays are great. Whenever I build any automation software, I build clear status pages that say what's happened, why did that happen, if there are planned actions or current actions, what those are. It's also really important to give people control. There should be a nice button that says, stop doing that right now, or do this right now. Because you always have more context and are better able to control things than the software. It's important to give full details of the execution steps for any planned process with everything, the configuration values, all the parameters, everything. This is something that we never see. I would love to see more of it in software. I would love to see things like estimation of resource usage, of particularly API quota usage. It's very common to, in large installations, you start running out of your AWS API quota. Same on other clouds. How much of that are you going to use if you're doing like a big cloud operation? Terraform is an example of this. Terraform do a bunch of things right. So they do tell you what's going to happen. They say, okay, this will be destroyed, this will be created. And this is, it's hugely better than what most software has. But you can still have nasty surprises. Because while it tells you where you start and where you end up, it doesn't actually tell you the full sequence of steps to get there. I have a friend, and genuinely this was a friend, it was not me, who took down a major website because he had decided that he wanted to increase the instance size or the amount of memory or something on a big fleet of servers. These were EC2 instances. So now, I know everyone who's worked with EC2 is saying, well, why didn't you update the launch template? He didn't. He actually tried to update all the instances, and the Terraform plan came up and said, okay, I'm going to destroy 1,000 instances and create 1,000 instances. And he was like, great, that's what I want to happen. because his mental model was that it was going to destroy one and create one, and destroy another one and create another one. And I think anyone who has much exposure to Terraform knows that that's not the case, sadly. But this is, like I say, quite good, but could be better. The other part there was he ran out of API quota, so again, that's why I say that estimates for that would be quite useful. Because again, we build automation in this quite simplistic fashion that tends to not take into account all this sort of valuable, useful context, like you're trying to, do 3,000 operations here, and that's 2 days worth of your API quota or whatever. Terraform also, like I say, it's very good, but it does hide warnings, which can be quite bad in terms of automation surprise. This happened while I was at Slack, and it's written about in, I've given the link here. This was, Slack had a bit of a mishap with DNSSEC, and part of the reason, and not the whole reason of course, but part of the reason, one of the contributing factors was that this very nice warning, which exists in the console, doesn't show up if you're managing things in Terraform. So again, we have interactions between tools that sort of end up hiding really valuable context from operators. Here's another example. This is a Grafana incident from 4 years ago. This is another sort of interaction issue, piece of automation here. This organization was rolling out Kubernetes pod priorities. So the idea here is you can say, these pods are high priority, these pods are medium priority. If you need more medium high priority pods, you can preempt your medium ones and get more high. Okay, this sounds great. This sounds like the sort of thing that you want. But their rollout went wrong because they brought up a new big cluster that had priorities specified, whereas the existing fleet did not. And the automation just happily went away and said, great, okay, I guess you don't need all of this other stuff anymore. Whereas it would be entirely possible if you were building the automation to bring up that cluster in a thoughtful way. You could say, okay, well, we're going to bring these up, and as a result of that, it is likely that these other pods will be preempted. Yes, it's more work. It is more work as a builder of tools to do this sort of thing. But this is where the work should be. It is, I think, incumbent on tool builders to spend the time to not build the minimum viable automation tools that we can build, but instead to try and build in these kinds of helpful hints for operators that you might be about to do something horrible. We don't do that, and we should do that. So here is my second kind of category of anti-pattern. And this is when you're kind of trying to build Clippy for prod. So there's been a bunch of human factors research on how do people deal with the unknown? And this is my callback to the theme of the conference. One of the hardest things I think we do when we're running software is to deal with the weird curveballs when something suddenly very strange happens and potentially very bad, and you do not know what is going on or why. So it's becoming increasingly common, I think, to try and build systems that diagnose problems for operators. And this is done in a well-intentioned way. People are trying to help. But the problem is, it's very difficult to build perfect automated diagnosis. And if I start making recommendations to you that, oh, this problem is probably because of the last release, you should roll it back. If that recommendation is wrong, it makes it harder for you to think about other things that could be causing it. Very literally, these kinds of recommendations, they make it harder for you to do your job if they're wrong, and they'll always be wrong some of the time. So, troubleshooting is all about keeping your mind open to as many different hypotheses as possible and not, going down that garden path until you have good evidence. So suggestions and recommendations are things that we should be really careful about. And you'll see this often, like people will start building health dashboards, and run books will often say, well, this alert is caused by XYZ thing. Are you sure it will always be caused by that? Just even using like softer language saying, in the past it has been caused by X, Y, Z, that's better than being definitive when you can never be definitive when you're building general tools or writing general documents because the world is full of surprises. I really worry about the AI ops hype cycle. People are trying to build all these like ChatGPT tools now to help us run our systems, and I think that we're likely to see a bunch of incidents where people are badly led down the garden path by these fancy ChatGPT tools. The other thing you see all the time is people go, oh, well, there's some sort of network error here, so it's probably the network, and then it's not the network, and you don't find out for hours. So be careful when you say, well, it's obviously the network. You may be misleading people. This is from a thing called the Stellar Report. This was written by a bunch of human factors people like David Woods, who went and tried to study how we do things here in software. And they looked at how people sort of try and deal with the unknown. And they scan through all these hypotheses, and they look through all these sources and look for weird things that seem to be related, and then they try and find more evidence, right? You're trying to generate hypotheses. How can we build our tools to support that instead of supporting these kinds of recommendations or suggestions? That's what we should be doing. So, summing up here, according to Joint Cognitive Systems, there are two types of tool. You can have an amplifier, or you can have a prosthesis. An amplifier lets you as a human do more things, but does not try to be your only interface with the system. So with an amplifier, you get to dig into the details if you want. You get to see what's going on. You get to define the whole steps of the process. I think in tech, the best example I can think of an amplifier might be something like Chef or Puppet or Ansible, these kinds of older configuration management tools, because you write the code that specifies what your system does, and you can test it by hand, and you can see all the logs, and it's not hiding much from you. It's just letting you do more in a repeatable fashion. And I'm not saying these tools are perfect, and I'm not saying that these tools never cause surprises, but I think they're the closest I can think of to the amplifier concept. Prostheses, they want to be your only interface into the problem space that you're trying to solve. They want to hide everything under layers of abstraction and encapsulate everything. They don't want you to know anything about the inner workings of what's going on. They hide a lot. And so with the best intentions, we build a lot of these in tech. I think pretty much any SaaS tool is probably a prosthesis. We build all sorts of libraries that are prostheses as well. Here's an example. This was at Cloudflare. They built a library that was trying to encapsulate all of the kind of complexity of being a Kafka client. And there's a lot of configuration and a lot of behavior around that. But they abstracted too much, and they had some issues about it. There's a really good blog about this. And I think this is a great example of hide too much complexity, and it blows back on you. So the first principle that we can say here is try and build amplifiers. Try not to build prostheses. And you have to build amplifiers in a thoughtful way. Like you can't just overwhelm people with everything. You have to summarize. But you also want to not be too definitive about, presenting lots of recommendations and suggestions. You want to provide the ability to drill down and explore the details and hopefully lead people on productive paths. But you want to make it possible for people to dig down into what is happening at almost the lowest level you can. Explain everything. Anytime there's an automated decision happening in your system, explain why that happened. If I scaled something up, if I scaled something down, if I decided that this thing was unhealthy and we should route stuff over here, if I decided to roll back something for an automated reason, explain all of that really clearly, make it very easy to find. And make your constraints and limitations clear. you can do this 10,000 times per day. You know, you can, and you've done it 8,000 times. You can use this many gigabytes of RAM, and you were at this. Try and expose all of that. And the general concept here is, instead of trying to encapsulate everything and, you know, make all the complexity be sort of part of the tool in that prosthesis way, you're trying to build ways that support people in building the mental model of what's going on. Because at some point, the unknown will happen, and they will need that mental model to figure out what to do. So, to sum up completely, avoid the things that lead to automation surprise, avoid building Clippy for prod, avoid building prostheses, but do build amplifiers. And with that, thank you very much. I think these slides will be published. Here is some contact information, and I loved being here. Thank you.
Thank you so much, Laura. As usual, Laura comes with a wealth of knowledge, dropping golden nuggets. And if anybody does have any questions, please make sure to link into our Twitter and ask us the questions, and we will have a Q&A session at the end of ShipItCon today. Our next speaker up to the ShipItCon stage is Kieran Carraher, who has a background in networking,